Alright, so we're going to go back over here and just start explaining some things. So I know there's a lot of concepts here that might be foreign. So right here we have something called positive sense single-stranded. So for RNA genomes, you have a positive sense and a negative sense. Like we saw up here, right here, it's 4 and 5. And so we're going to talk about them each individually. And right here, positive sense. And so positive sense can act as an mRNA, actually. And so positive sense RNA, single-stranded RNA, is infectious, which means right as it goes into the cell, it can be directly translated by ribosomes within the host cell. So since positive sense single-stranded RNA can act as an mRNA, they don't need to carry RDRP into the cell. It actually is coated on a polyprotein. So right here, we have one long polyprotein and a portion of this, let's say it's right here, a portion of this will code for the RDRP. All right, and so once the RDRP is formed, we'll put this as step 1. Once the RDRP is formed, go down here to step 2, and it creates a complementary negative sense RNA strand. It's called the antigenomic RNA. And so we get the positive sense strand goes to the negative sense strand by way of the RDRP. All right, this negative strand is used to then make the positive strand again. So this might seem sort of weird, but you can't, you have to replicate the genome to put back in the capsid for assembly. And so you can't make positive sense RNA from positive sense RNA. You can only make positive sense RNA from negative sense RNA. So, what we're going to do now is we take the negative single-stranded RNA from up here, from right here, and sorry guys, I keep doing that. We make positive single-stranded RNA. There's the RNA. And so this right here is what gets packaged into the nucleocapsid. I'll write that here. All right. So some notable examples of, single-stranded RNA viruses, we will stick those up here, are Norwalk virus. You might have heard of this. This is a cruise ship virus. Let's see. We also have yellow fever, dengue virus, and one that has been in the news within the past few years is West Nile virus. You probably recall the outbreak that was in 2014/2015. And then a few hepatitis viruses, polio viruses, and rhinovirus. So this is it for the positive sense single-stranded RNA. So we are going to change colors, come down here, and move on to class 5. Now class 5 is negative sense single-stranded RNA. So I'm going to go ahead and write the process out, just like all the other ones. So we start with the negative sense genome that comes within the virion. And we're going to use RDRP to get to the antigenome. So just like before with the positive where we went to the negative, right here we're going from the negative to the positive. Then we're going to keep going with RDRP. And we are going to go back to the single-stranded RNA genome. So it's pretty much the same process. If we zoom out a little bit up here where we're looking, we go from the genome, use RDRP to the antigenome, the RDRP go back to the original genome. Down here, we go to the genome, RDRP, antigenome, RDRP, back to original genome. All right. Oh, goodness. Okay, so that is how the genome is replicated, but now we have to make the protein shell, the capsid. So here we go from the genome, we use RDRP, and we make mRNA. The extra step here going to mRNA is because, like we set up here, how this is infectious. The positive sense RNA is infectious. It means it acts like mRNA, but the single-stranded RNA, the negative sense single-stranded RNA does not act like mRNA. And so we have to first transcribe the genome into mRNA. Then we translate. And it is translated into proteins, of course, to make the capsid. And then finally, these two things are put together in assembly. All right. So like we said before, just to highlight a few things that are important, these are not infectious. They have to carry RDRP. So not infectious. All right, and also I think I noted this about the positive sense RNA, but something that's important about these viruses, the single-stranded viruses of RNA, is they actually occur, all their, the steps of transcription and translation occur in the cytoplasm because they don't actually have to use any of the host machinery. All right, so we have gone through how this works, and I'm going to write out some examples here. Some examples of negative sense single-stranded RNA, something you've obviously probably heard of is Ebola virus. Some less common ones that you might not have heard of are Marburg virus. Let's see, we also have Lassa virus. And let's pick one that we've probably all heard of before. Oh, rabies definitely is an important one. And also influenza A and B. I'm not trying to include a lot of examples because I know you'll probably get lost in all of these names, but it's interesting to just know that there are things in each of these categories that you are able to, really just have experience with and have heard about in the news, or maybe have encountered some of these like influenza yourself. Okay, there's one more facet of negative sense single-stranded RNA viruses that we have to talk about, and they are called ambisense viruses. In ambisense viruses, as the name suggests, you have ambi, which is both, and sense, which is, well, positive and negative in this case. And so that just means that these viruses have a partially negative and a partially positive sense genome. And this only happens with the RNA. This does not happen with the DNA. All right, they are categorized with the single-stranded RNA viruses because the positive sense portion of their genomes is not translatable. The negative sense portion of their genomes is not translatable like the positive sense. So, as you remember a second ago, we said this positive sense is infectious, which means it is translatable immediately into, or it acts as mRNA. So for ambisense viruses, the RDRP helps to transcribe the negative portion into mRNA, while the positive portion must be transcribed into negative sense. So the negative uses RDRP, and it is transcribed into mRNA, whereas the positive sense, like I just said, goes to negative sense and then to mRNA. All right, and this is all done with the help of RDRP over here. And this is just a really weird subcategory, but there are definitely viruses that I bet you've heard of that are in this category. We have certain arena viruses, which are transmitted by rodents. And like we said over here, one of these is Lassa virus. I'll just go ahead and put it over here again, because I put it over there because technically, like I said earlier, it is categorized as negative sense single-stranded RNA, but just to be more specific, I will put it over here as well. And then also, we have something called lymphocytic. Let me write this. And hopefully I say it right. Lymphocytic choriomeningitis. All right, and these are just examples, like I said, of viruses within this subclass. Cool. So now we're going to go all the way back up here. Oops. And the only ones we have left to talk about are the retroviruses.